Hello, students of physics. Well, I thought I should talk about the basic kinematic equations for a student who is trying to study physics for the first time. This could be frustrating. So here are the equations, and I'm going to work out 7 very important questions to show you how to apply these equations and not be frustrated. So here we go. First, let me introduce the equations. Now, all of these equations have 5 terms, but each equation involves only 4 of them. I'll let these equations roll. So here we have the 4 equations. We'll look at that later. The 4 equations here. Vf is the final velocity, v naught is the initial velocity, a is the acceleration, t is the time. And in this equation you have delta x, which is the displacement. And the third equation, we have no final velocity. In the fourth equation, we do not have acceleration. Now, why am I telling you this way? Because when you read a problem, you need to figure out what is given and what you have to find out, and all of those quantities should be in the equation that you plan to use. Or you will see that as we work out problems. But before that, there is an important equation which is very cute, and students tend to use it all the time, but beware. You can only use this equation when you're absolutely sure that there is no acceleration. That means it has limited application. You must be sure that the object is moving with a constant velocity in order to use this equation. Delta x is velocity multiplied by time. That has limited application. Now we also notice that there are 3 types of units that come in here. Meter is the unit of displacement. Meter per second is the unit of velocity. Meter per second squared is the unit of acceleration. And of course, second is the unit of time. So actually there are 4. Meter for displacement, meter per second for velocity, meter per second squared for acceleration, and second for time. So here is our first question. A bird accelerating from rest at a constant rate experiences a displacement of 25 meters in 15 seconds. What is the final velocity after 15 seconds? So let's read that again. A bird accelerating. Okay, so this bird is accelerating. So we can use the equations that involve acceleration here because it's accelerating at a constant rate, experiences a displacement of 25 meters. See, the unit is meters, and that's displacement, so that is delta x in 15 seconds. So that's the time. So you have delta x, you have time, and it says it's starting from rest. So the initial velocity is 0, and you're asked to find the final velocity. All right, let me list that down. So you got to list down the quantities. Initial velocity is 0. Displacement is 25 meters. Time 15 seconds. And final velocity is to be found out. Now when you look at all those equations, which equation has all these 4 terms? It's this one. Delta x is v naught plus vf by 2 times delta t. So as soon as you figure out that this is the equation, the rest is math, but you got to be careful, okay? And then you have 25 is equal to 0 plus Vf by 2 multiplied by 15. And then 0 is when you add 0 to anything, you just neglect it, right? So it's Vf by 2 times 15, which I've written as Vf times 15 by 2. So when I rearrange, it becomes Vf is 25 times 2 by 15, because when this goes to the other side, 2 goes to the top, 15 comes down. And when you calculate, you get 3.3 meter per second. That's how this problem is worked out. And now, here is the next one. A basketball player can jump 1.6 meters off the hardwood floor. With what upward velocity did he leave the floor? So you got to visualize that. A basketball player is jumping. Now you may think he's at rest, which he is. But if he has to go up, he has to give himself a certain velocity, and it can't be 0. Remember, whenever an object is going up against gravity, its initial velocity cannot be 0. So you got to find that initial velocity. With what upward velocity did he leave the floor? So you're looking for the initial velocity, V0, okay? And since this is something against gravity, the acceleration is always negative 9.8 meter per second squared. So we got the acceleration. We got to find the initial velocity. We have the acceleration, and it says he can jump 1.6 meters up. Now, up is along the y-axis, so I'm going to call it delta y instead of delta x. It's the same thing, delta y. So we have delta y. But we also have a very important quantity, because we need 4 quantities. Right now we only have 3. So what is the 4th quantity that's important? Could you figure that out? When he jumps at the highest point, his velocity becomes 0. When you throw any object up, at the highest point, the velocity of the object becomes 0. Yes, so we have all the 4 quantities. Let me list those down. We're looking for V0. Delta y is 1.6 meter. Acceleration is negative 9.8 meter per second squared. And we know that the final velocity at the highest point is 0. Now let's look at the equations again. Which one? Which is the equation that has these 4 quantities? Remember, there is no time, no mention of time. Time is not given, and time need not be found out. So we're looking for an equation that does not involve time. And yes, you got it. This is the equation. Vf squared is equal to V0 squared plus 2a delta y. Substitute the values carefully. 2 times negative 9.8 times 1.6. Remember, Vf is 0 and 0 squared is just 0. So you write V0 squared again, and then all of this becomes negative 31.36 when you multiply these 3 terms. And then you switch this negative to the other side, it becomes positive. So you have V0 squared is 31.36, or you take the square root of 31.36 to get V0 as 5.6 meter per second. So the basketball player launched himself up at that initial velocity. And here now is the next question. A cart is given an initial velocity of 5 meter per second, so that's the initial velocity, and experiences a constant acceleration of 2.4 meter per second squared. So that's the acceleration. You have the initial velocity V0, you have the acceleration 2.4 meter per second squared. What is the magnitude of the cart's displacement? Now, don't you be worried about the word magnitude. Magnitude just means how much, the size. That means you do not need to find the direction, just the number. Okay, so what is the magnitude of the cart's displacement? So you're looking for displacement after or during the first 5 seconds. So that's the time. So here are the given quantities. The initial velocity, 5 meter per second. The acceleration is 2.4 meter per second squared, there, right there. And you're asked to find the displacement, which is delta x, and time is 5 seconds. All right, which is the equation? Well, you saw a part of it. The equation is delta x is v naught t plus 1/2 at squared. Yes. Now, delta x is 5 times 5 because time is 5. Initial velocity is also 5. 5 times 5 plus 1/2 times 2.4 times 5 squared. 5 times 5 is 25. And then this quantity happens to be 30. When you add them, you get 55 meter. Oh, so here is another question that is really kind of different. Because when you read the question, it says, a railroad train travels forward along a straight track at 90 meter per second for 1000 meter, and then travels at 70 meter per second for the next 1000 meter. What is the average velocity? Average velocity. So you give them two velocities and two displacements. You can see. First, it's moving fast at 90 meter per second for the first 1000 meters. Then it's traveling at 70 meter per second for the next 1000 meter. You're asked to find the average velocity. You're given two velocities. So maybe you think you just add the two velocities and divide by 2. No, that's not right. That's not right, because average velocity is total displacement divided by total time. Now we know that the total displacement is 2000 meters because it first moved 1000 meters, then again moved another 1000. So the total displacement is 2000 meters. But we do not know the time that it took. We can find the time that it took in the first case, and so again find the time that it took in the second case. Add the total times, we will get the total. Add the two times, we will get the total time. Let me show you how it is done. Average velocity is total displacement divided by total time. Now, to find the time in each case, we will list it down. First case, delta x is 1000 meters and the velocity is 90 meter per second. Time is displacement by velocity. Remember the cubed formula, which you can only use when it's moving at constant velocity? This is that case. So, because delta x is velocity multiplied by time, rearrange that to get time as displacement by velocity. That gives 1000 divided by 90, which will give the time as 11.11 seconds. Okay, I'm going to change that to 11.1. Anyway, you got the idea. Do the same for the second case and find the time. In this case, the time, t2, is again delta x by velocity. It's 1000 divided by 70 this time. And 1000 divided by 70 is 14.3. So now we got both the times. We have the total displacement as 2000. We have the total time. And okay, I'm looking at significant figures and all that and changed it. And then finally you get the answer as 78.8 meter per second. So average velocity is total displacement divided by total time. Now, this is the next question. A speeding car traveling at a constant velocity of 24 meters per second passes a police car initially at rest beside the roadway. So the cop is just lying there in wait. And then the speeding car just passes by. If the police car with constant acceleration of 3.0 meter per second squared immediately pursues the speeding car, how far down the road does it draw even with the speeding car? So now you have two objects. One is the speeding car, the other is the police car. Now the speeding car is moving at a constant velocity, isn't it? So we can use that cute little equation because it's moving at constant velocity. The police car was initially at rest and then accelerates. So we cannot apply the cute equation. We got to use the equations that involve acceleration. And if you read the question, you know the initial velocity of the police car is 0. The acceleration is given as 3.0. And we have nothing else. We only have two quantities. We do not have the time after which the cop gets even with the speeding car, neither do we have the displacement. That's why this problem may be tough for a few of you. But after you list it down and you think, you understand this, that if this was the speeding car just passing by and this was the cop taking off, you know that they travel for the same time and then they travel the same displacement. All right, so from one point till they get even, the displacements are the same and they both take the same time. That's very important. So here it is. For the speeding car, 24 meters per second. For the cop, the initial velocity is 0. Acceleration is 3.0 meter per second squared. We do not know the displacement. We do not know the time. Now for the cop, we know, for the speeding car, since it's moving at constant velocity, we can use this equation. Delta x is velocity multiplied by time. But for the cop, if you look at the quantities, you know that the equation that involves these four is delta x is v naught t plus 1/2 at squared, which sometimes I call the king of all equations. And when you substitute, this term becomes 0 because v naught is 0. Then you have 1/2 times 3 times t squared. Now 1/2 times 3 is 1.5, so 1.5 t squared. Okay, so now we have two equations. Look at the two equations. Here's the first and the second. Delta x, as I told you, is the same for both, right? That means the left-hand sides of the equations are equal. If the left-hand sides are equal, then we can put the right-hand sides equal to each other. That's what I'm doing now. 24 multiplied by time is 1.5 t squared. So now we got to find the time. Divide both sides by 1.5 t. And then you get the time as 16 seconds. Once you get the time, you just plug in the value of time into any one of the equations. Or maybe into this because it's easier. So delta x is 24 times 16, which gives 384 meters. So the police car gets even with the speeding car after a time of 16 seconds and after a displacement of 384 meters. And here is the last question. A rock is thrown straight up with an initial velocity of 17.6 meters per second. What time interval elapses between the rocks being thrown and its return to the original launch point? Acceleration due to gravity is 9.80 meter per second squared. Okay, this could be a tough question because if you look at it, you have the initial velocity, which is 17.6 meter per second, and you also have the acceleration, which is negative 9.80 meter per second squared. Acceleration is taken as negative all the time, acceleration due to gravity, because gravitational force is downwards, and that's negative. So these are the only two quantities that we have. And then we are asked to find the time. So that's the third. But we can't work it out with three quantities. We at least need four. So what is the fourth quantity? So the important thing is to read the question again. It says, what time interval elapses between the rocks being thrown and its return to the original launch point? So if it starts from here, it goes up and comes back to that point, right? Therefore, the displacement is zero. Displacement, that's our fourth quantity. So here are the quantities. Remember, if anything returns to its original position, its displacement is zero. So once again, I'm calling it delta y because it's along the y-axis. Here are the quantities. This is the equation, the king of all equations. Delta y is v naught t plus 1/2 at squared. And then substitute into that, delta y is zeros, and then 17.60 plus 1/2 times negative 9.8 times t squared. So don't panic when you see t and t squared. Don't get worried. Just simplify this. First, 1/2 times negative 9.8 is negative 4.9. So in the next step, nothing else changes except I put negative 4.9 t squared. Okay? Because positive multiplied by negative is negative. So once you get negative 4.9 t squared, next up, you take that negative 4.9 t squared to the left side. Becomes positive 4.9 t squared. And after that, you divide both sides by 4.9t. When you divide both sides by 4.9t, you finally get t is equal to 3.60 seconds. I really and sincerely hope that you understood how to work out these problems. As a first timer trying to do kinematics questions can be really frustrating. But let me tell you this, if you are persistent and if you try to do the problems on your own, even though it's a struggle, you are going to get it. So good luck in understanding kinematics. Remember, this is the most basic chapter and we build on this chapter. So it's really important that you understand the workings of this chapter. All right, see you on the next video. Thank you.